1 over x.
Careful, it cannot be 1 over x. It's the differential of u, not the derivative of u.
Oh, dx.
Excellent. Awesome. That's the u. And this will be the square root of u. Perfect. So the integral from du over the square root of u. When x is the lower limit, how much is u?
Zero.
Would it be 1?
1. Natural log e is 1. Very good. When I have x as e to the fourth, what do I get as the upper limit for u?
4.
Very good. Awesome. Okay, so then this is u to negative 1/2 plus 1. So this will be u to 1/2 over 1/2 from 1 to 4. So 2, the square root of u from 1 to 4. 2 outside waiting patiently. The square root of 4, 2, minus the square root of 1, 1. 2 minus 1, 1 times 2. So all this is a positive function on these two. This is positive, and this is positive because it's the square root. It's continuous on this interval. It will not be continuous at 0 and 1, but 0 and 1 are not here. So continuous positive function on this interval, I have to get a positive number as the answer. Okay, I got my eye on at least one more, if you agree with me. Any questions on this? Do we feel a little bit better? I know I repeat myself like a broken record, but I'd like to see if this is better or not.
I mean, I'm feeling better.
Awesome, thank you, Dylan. So here's another 79. Let me know if this is not a good color. 0 to 1 dx over 1 plus the square root of x to the fourth power. The function is continuous. It will not be continuous. I mean, this is always positive, so no matter what, it's plus 1, right? So definitely between 0 and 1, this is always positive. The power is positive, is even, so everything is positive. The answer has to be positive, and it's continuous on 0, 1. So all conditions are fulfilled, we can proceed. So if we want to use u, what will that be?
One plus the square root of x.
I agree. So now let's see what we do with du. Anyone?
1 over 2 square root x dx.
Excellent. Well, I have a little bit of a problem here. I can make up the 1/2, but I cannot make up the square root of x. So now I will solve for dx. But when I solve this equation for dx, I multiply both sides by 2 the square root of x du. But I have a problem because I can't have u and x. What do I do with this piece? I cannot have in the same part of the equation side, I cannot have x and u. What do I do with this? Any suggestions?
Could it be u minus 1?
Exactly. The square root of x will be u minus 1. So in this particular case, I could not do that little quick trick with a 2 and a 5 and a 7 and an e or whatever. I could not. That is a shortcut. It's a nice trick, but in this case, it did not work. So now let's see. Do not copy the limits of integration. Let's determine them right now. When x is 0, how much is u?
One.
Excellent. When x is 1, how much is u?
One half.
When x is 1,
2.
exactly. And now we have to be very careful. I have to replace, so the denominator is easy. There is no problem there. I don't have any problem with u to the 4th. But I have to be careful what I do next. Dx is 2, fine. I cannot put in the square root of x, but I can put in u minus 1, and then du. So careful, when you move from an integral to x, you have to completely move to u. You cannot have x and u, you cannot have x and u. Okay, now I'm back to realizing that the denominator is one term. This is a piece of cake, basically, most of the time. I can generalize. 2 is outside waiting patiently. U over u to the 4th is u to negative 3 minus 1 over u to the 4th is u to negative 4 du. One more time. 2 was outside because it's a factor. U over u to the 4th, I simplify. From power 1, I subtract power 4 and get negative 3. And then negative 1 over u to the 4th is the same with u to negative 4. So therefore, I have 2, u to negative 3 plus 1, so u to negative 2 over negative 2 minus u to negative 4 plus 1, u to negative 3 over negative 3 from 1 to 2. It's a little bit of a mess. Okay, so let's clean it up first. 2, this is negative 1 over 2u squared, and minus with minus will be plus 1 over 3u cubed. I had to clean it up before I plug in. So what I would like you to do on the test is just plug them in and don't calculate by hand. Use the feature in the calculator. I'm fine with that. So what I want you to copy is this. 2 squared, 4 times 2 is 8, plus 1 over, this is 8, 24, minus, when I plug in 1, but this becomes positive, and 1 with, it becomes negative, 1/3. I don't want the arithmetic, because this will take, it could take 10 minutes. I don't want that. So from here, I just want a number with a calculator. I will even give full credit if you don't even do that. I don't care. But if you want to check, so this is not a test in arithmetic. I'm assuming that you know how to add these, and if you don't know how to add these, then it's not the time to start right now. Okay, I'm fine. So all I want you to write is this, and if you want to put a number, fine. If I see that this is correct, then I assume that you will be able to do the arithmetic. I don't want you to waste time on the arithmetic on this. I don't care. I will finish it up because I don't like to leave stuff in the middle, and then we can even check. So I think I'm going to use 24, and this needs a 3. This one needs doesn't need anything. This one needs a 12, and this one needs an 8. Okay, so negative 3 plus 1 minus 12 minus 8. So I'll simplify, so this becomes 12. And let's see what I have here. This is negative 20, negative 23, negative 22. Let me look and see how.
Times 2, right?
I'm sorry?
Times 2. Oh, sorry.
I simplify.
Sorry.
No, that's okay. I'll rather check. Okay. I am expecting a positive number. We're going to check in a moment, but so 75 by 2, yes. So I have negative 11 over 6. So let's look again. Between 0 and 1, this is a positive function. Okay, so 2, I'm checking all my calculations right now. So that was correct. Then u minus 1. Yes, that's correct.
I think at the end you forgot to change the sign. Where it should have been plus, I think it was still a negative. Where it should have been plus 1/2 after the 1 over 24.
Yes, this one is the positive, yes. I said positive and I wrote negative. Okay, thank you so much. Yes, so when I plug in negative 1, but when I plug in 1, this will become negative, positive, and this will become negative. Thank you so much, yes. I did say it, but I didn't write it. Thank you very much. So what am I doing here? So this is 13 minus 10. Minus 3 is 10. 10 minus 8 is 2. So it's 2 over 12, which is 1/6. It's always good to go back and check and say from the beginning that this should be a positive number. That's not always possible, but let me share my screen here. And where is my calculator? Here it is. Okay. I think it's number 9. Yes. So this was 0 to 1. Be careful how you enter it. Don't enter the antiderivative or anything like that. Be careful if you want to check. So the function was 1 over. Don't forget parentheses. You may get something else. Be very careful with this. Okay, this time, okay, I'm not going to put parentheses around x. Okay, so power 4. So it's 1 over that. That's correct. So now if we don't get point what? Okay, so that's what we are looking at. It's not going to, sometimes it's not going to, but 1/6 is that. So that's why I realized that the number made no sense. And thank you, Katie, for picking that up. I mean,
Oh, that was not me. Someone else picked that up.
Okay, sorry. Who was it? Was Sarah or Rachel? Okay, sorry.
Yeah, it was me.
Thank you so much. I appreciate it. I said changes and I didn't write it. So I realized that something was fishy here because I knew from the beginning, and that's what you should always do. Look at the function, check continuity, say, oh, it's always positive here between this and this, and so then the answer has to be positive.
I have a question about
Yes.
this.
Yes?
Where it went to u to the negative 3, how did we get that?
This one?
Yes.
U to power 1 over U to power 4. I copy the base and subtract from the power of the numerator. I subtract the power of the denominator to get negative 3. So a to n over a to m is a to n minus m. N minus m. So if this is 1 minus 4 is negative 3.
And the negative 1?
1 over a to the nth power is a to negative n. One.
Okay.
Is that okay now?
I think so.
Okay, let me know.
Will we have stuff that's involved on the test?
I'm sorry?
Will we have stuff this involved on the test?
It's just algebra, really. It's not a big deal. These are exponential rules. This is very important. Exponential rules are very important. Okay, one thing I wanted to mention is something called the net change theorem. Net change theorem. Remember in chapter 3, we looked at the particle that was going in the positive direction with a positive velocity, and then it was going back some seconds with a negative velocity, and then it was coming back with a positive velocity. So here the velocity is positive, here the velocity is negative, and here the velocity is positive, right? How did we determine the total distance? Anyone remembers how we determined the total distance for something like this? What did we do?
I think we didn't we take the absolute value
Exactly.
of the distance?
Yes, exactly. In this way, in this direction was absolute value between this and this, and then absolute value between this and this point, and then the absolute value between this point and this point. Excellent. Now, what does this really mean? It looks something like this. The velocity function, so it's positive first, and then it's negative, and then it's positive. Or going up, it doesn't matter. Okay? So positive here, positive velocity, negative here, negative velocity under the x-axis, and then positive velocity again. Now, how do you think we're going to determine, because now we have more information, how will you determine the total distance at this point? So remember, this is the function that is a velocity. And what did we say when we first discussed this situation? The simplest possible function that I can come up with that x squared. And I said, if this is the velocity, what is this? Let's say between 0 and 5.
Is it the distance traveled?
Exactly. This area will be the distance. Exactly. Perfect. So then how do you think we're going to determine the total distance between 0 and 10?
Take the areas.
Exactly. The integral from 0 to 10 from the absolute value of v of t dt. This is going to be positive. I don't even need the absolute value. This is going to be positive. I don't even need the absolute value. But I need the absolute value for this to move it up instead of being down. Because I still have to add. I cannot subtract this area. The particle covered this distance. So it has to be positive. So I will have this area plus this area, which is the mirror image of this area, plus this area. So in general, so there is a net change theorem for a lot of things, for mass, for concentration, from volume, for you name it. We are only going to look at the total distance, the net change theorem for the total distance. And here is the total distance is the integral from t1, first time 1, to time 2, the end, from v of t dt with the absolute value. This is it. Which is what we did before, but we didn't know integrals then. So let's choose a problem. And this is the end of the course. That's the last thing I needed to show you. So I'm looking for, here it is. Let's look at problem. I'm in 5.4. This is in 5.4. Which page am I on? I'm on page 9. So this is from 5.4. And let's start with 69 and also look at 70, both of them. So we have v of t equals 3t minus 5 from 0 to 3. We're asked to find two things. Number one, find displacement. Of course, this is the velocity. Displacement. What is a displacement? Here is the displacement. The particle started here and ended here. This is the displacement. You can do whatever, but it ends here. This is the displacement. So let's find it. So by definition, the displacement is simply the integral from 0 to 3 from v of t dt. Which is 3t squared over 2 minus 5t from 0 to 3. Luckily, I don't have to plug in 0 because this will be 0. Careful, if it's e to something, it's not going to be 0, but it's polynomial. It's a polynomial. So I only plug in 3. So 9 times 3, 27 over 2 minus 15. I'm okay if you just leave it like this. You plugged it in. You showed me that you know how to plug it in. If you don't want to calculate, you don't have to calculate. And this displacement can be positive or negative. So this is 27 minus 30 over 2. So this is negative 3/2, and this is meters. Let me see. Meters per second is the velocity. The distance. Okay. Now, the second question is total distance. Different story. Totally different story. Because with the total distance, we are doing this. So that will have to be the integral from 0 to 3 from the absolute value of 3t minus 5 dt. In which, of course, we have to start with the absolute value of 3t minus 5. We get those two options, the 3t minus 5 and negative 3t plus 5. When 3t minus 5 is positive or 0, t greater than or equal to 5/3, and t less than 5/3. So then I know that 5/3 is between 0 and 3. Of course, this has to be a positive number. There is no discussion there because this is a positive function. This is not a positive function on 0, 3. But this is definitely a positive function on 0, 3. So the answer has to be positive. So then I have to break it up from 0 to 5/3 from this, and from 5/3 to 3 from this. So then I will write 10, the integral from 0 to 5/3 plus the integral from 5/3 to 3. And again, 0 to 5/3 is from this. And from 3t minus 5 dt. Okay, so then that's easy. Negative 3t squared over 2 plus 5t from 0 to 5/3. And plus 3t squared over 2 minus 5t from 5/3 to 3. This is an awful calculation because of this 5/3, right? So I have to be careful. So negative 3/2 times 25 over 9 plus 25 over 3. Luckily, I don't have to plug in 0. Good. Plus 3/2. Okay, so this is 27. 27/2. And this is minus 15. Minus, so I don't forget. So 3/2 times 25 over 9 and minus 25 over 3. Okay, 75 over 18 plus 25 over 3 plus 27 over 2. This is what I don't want you to spend time on the test or the final. Okay, minus 75 over 18 and plus 25 over 3. So I'm just going to say etc. But I really would like to get this number though, however. So I have negative 150 over 18. And then I have plus 50 over 3. And then I have plus 27 over 2 and minus 15. Okay, the least common denominator is 18. What do I need here? I need a 6. What do I need here? I need a 9. And here I need an 18. Okay, so where's my calculator? So 9 times 27, it's, okay, and 18 times 15. So this is 243 minus 270. and then negative 150 plus 300, I should have written 150, plus 243, minus 270. So I got 123 over 18, and when I divide, I get roughly 6.83 meters. Okay, now be careful if you want to check with the graphing calculator, be careful how you